students, now we are presenting third video of sound lesson. In the last video, you understood that sound travels in the form of compressions and rarefactions. In this video, we are going to understand the characteristics of sound waves. So, before knowing the characteristics of sound waves, let us first understand these graphs, how sound waves can be represented in the form of a graph. Okay. So, I have represented sound waves in the form of graphs here. Here the x-axis represents distance, y-axis represents density or pressure variations. Now you can see, you already know that sound waves travel in the form of compressions and rarefactions. And these compressions are nothing but high pressure area. So here you can see, I have represented compressions in the form of crust and rarefactions in the form of trough. As you know that sound wave travels in the form of compressions, rarefactions. Here also, sound waves are moving in the form of crust, and trough. And one crust and one trough together makes up one sound wave. So one sound wave is nothing but one crust and one trough. Okay. So in one sound wave is also called as one oscillation. This is about the two graphs. I think you understood both the graphs now. Now let us understand the characteristics of sound waves depending on these graphs. Okay. Let us start with the first one. The first characteristic of sound waves which we are going to learn today is wavelength. Name itself says, what is wavelength? Wavelength is nothing but length of a wave. So now we already know that what is one wave. What is one wave? One wave is one crust and one trough together. So wavelength is one crust and one trough together. This is called as wavelength. And wavelength can also be defined in many other ways. One more common definition for wavelength is wavelength can also be told as distance between two consecutive compressions. Now you can see here. So these are the two consecutive compressions and distance between these two is also called as wavelength. So here also you can see, if we take these two waves, half of these two waves, that also forms one more crust only. So that is not a new definition. This definition only is told in a different way. So distance between two consecutive compressions is also called as wavelength. And what can be the one more definition for that? Yes. The distance between two consecutive rarefactions is also called as wavelength. Now let us know what might be the SI unit for wavelength. You already know that SI unit of length is meter. So SI unit of wavelength is also a meter because wavelength is obviously length, but it is length of a wave. So it is also expressed in the form of meter. And there is one more representation for wavelength. Wavelength is represented by lambda. This is called as lambda, Greek word. Okay, Greek letter. So let us analyze these two graphs on the basis of wavelength. You see the graph A and graph B. Let us see which has more wavelength. By looking at these two graphs only, we can make out that graph A has more wavelength than graph B. So what is the wavelength of graph B? If we calculate, wavelength of graph B is only about this. So if we see graph A and graph B, graph A has more wavelength and graph B has lesser wavelength. I think it is clear about wavelengths now. Let us go to the second characteristic, that is nothing but amplitude. What is amplitude? So when we see the graph, we see that this is called as mean portion. It is the normal portion. And this represents high pressure area, which is compression. And this represents low pressure area, which is rarefaction. So what is amplitude? Amplitude is the maximum displacement from this mean portion. It represents highest pressure or maximum displacement from the mean position. In the second graph also, it represents maximum displacement from the mean position. This is called as amplitude. And this maximum displacement can be either side. It can be towards compression side or the rarefaction side. Both the sides you can take. And this is represented by the letter A. And if you let us analyze this amplitude on the basis of these two graphs now. Now see, in these two graphs, when you compare, which one can have highest amplitude? If you just look at these two waves, you can understand that graph B has highest amplitude and graph A has lesser amplitude. So amplitude is more in graph B, less in graph A. Now let us understand third characteristic of sound waves, which is frequency. You already have a word in English which is frequently. What is the meaning of frequently? If you do something many times, then you say that is frequently. So in the same way, if a sound wave passes through a given point many times, we call it as frequency. It is like this. If you stand at a point and count how many waves pass through that given point in 1 second, it is called as frequency of that sound wave. So what is frequency? Frequency is number of sound waves passing through a given point in 1 second. Number of sound waves can also be told as number of oscillations. So number of oscillations per second is also called as frequency. And frequency is again represented by a Greek letter nu. And SI unit of frequency is hertz. So frequency, if you see, as for the simplicity, I have represented frequency by F. Frequency is also called as, also known as cycles per second. Let us analyze these two graphs on the basis of frequency, which we have learned now. Okay, so if you see the first graph here, you can see that wavelength of this wave is more. So if I stand here and count how many waves pass through the given point in 1 second, let us assume it is x. X waves pass through the given point in 1 second. Let us go to the second graph. Now, if I stand here and count number of waves passing through this point in 1 second, will it be more than x or less than x? Of course, it will be more than x because here the wavelength is less. So, see, because the waves are very small here, so number of waves passing through the given point will be more here compared to this. So, by analyzing these two, you can easily understand that if the length of the wave is more, number of the waves passing through the given point will be less. And if the length of the wave is less, number of the waves passing through the given point will be more. So, from this you can easily understand that if wavelength is more, frequency will be less. If frequency is more, wavelength will be less. So, as frequency increases, wavelength decreases. So, as wavelength increases, frequency decreases. Now, let us go to the next characteristic of sound. That is time period. What is time period? Time period is nothing but time taken to complete one oscillation. So, what is one oscillation? One crest and one trough together is called as one oscillation, and time taken to complete this one crest and one trough is called as time period. Now, this one, or else you can say this as time taken to complete one compression and one rarefaction also. This is nothing but time. So, what is the SI unit of time? SI unit of time is seconds. Like this only, SI unit of time period is also seconds. And time period is represented by capital T. Now, let us understand the difference between frequency and time period. Let us make the things simple by understanding this through a simple example of your daily life. Imagine that you are riding a bicycle. So, your bicycle has a wheel. Let us say that one complete rotation of your bicycle wheel makes up one oscillation. So, what is the what is the time period of your bicycle? Time taken to complete one rotation or one oscillation is nothing but the time period of your bicycle. Now what is the frequency? How many times the wheel of your bicycle rotates in 1 second is its frequency. Understood now? What is time period? Time taken to complete that one oscillation or one rotation. What is frequency? How many times the wheel rotates in 1 second. Now, if you are riding your bicycle very slowly, now if the speed of your bicycle is less, then the time period is more. But the frequency will be very less because cycle is going very slowly, so number of rotations are less. Now if you are riding the bicycle very quickly, that means if speed of a bicycle is more, then the time period will be less because time taken for one oscillation here is less, but the frequency is more because wheels are running very fast now. Because speed is more, number of oscillations in 1 second is more. Now, if we observe in these two cases, in the first case, what happened? Time period was more, but frequency was less. In the second case, time period is less, but the frequency is more. When one quantity is decreasing, another quantity is increasing. When one quantity is increasing, another quantity is decreasing. This shows us the inverse relation. This shows that frequency is inversely proportional to time period. Frequency is inversely proportional to time period. We can observe the same thing in these two graphs also. In the first graph, time period is more, but frequency is less. In the second graph, time period is less, but frequency is more. I think this is clear now. What is the relation? Frequency is inversely proportional to the time period. Now let us go to the last characteristic of sound wave, which is called as speed of a wave. Speed you have already learned in the first lesson. What is speed? Speed is distance traveled over time taken. Now we are talking about a sound wave. So speed of sound wave is distance traveled by a sound wave divided by time taken to travel that distance. That is distance by time. Now distance traveled by a sound wave, one wave, is nothing but wavelength, which is represented by lambda. Now what do we call the time taken to travel this distance? What is this distance to travel this one oscillation, one crest and one trough? That is now only we understood. That is nothing but time period. So that can be represented by capital T. So speed of a sound wave is nothing but wavelength divided by time period. But we already know that 1 by T is nothing but frequency, F. So if we substitute this value in this equation, then lambda by T becomes lambda into F. So now finally our relation for the speed of a wave is V is equal to lambda into F, where lambda represents wavelength and F represents frequency of the given wave. Now let us go to the last characteristic of the sound wave, that is speed of the sound. Speed of the sound wave. Now in the first lesson only you have learned how to find the speed. So speed is nothing but distance travelled over time taken. Here we are finding the speed of a sound wave. So here we have to find speed is equal to distance travelled by a sound wave divided by time taken by a sound wave. We already learned that distance travelled by a sound wave is nothing but wavelength, and time taken by a sound wave to travel this distance is nothing but time period. So speed is represented by, for speed, distance travelled is represented by lambda, which is nothing but the wavelength, and capital T, which is nothing but the time period. So speed of a sound wave is nothing but lambda over capital T. But we already know that 1 by T is nothing but the frequency of the wave. So if we substitute this value in this equation, then it will become lambda into f. So our final equation what we get is speed of the wave is equal to lambda into f. So let us have a quick recap of what all we learned in this video. So first characteristic we learned was wavelength. What is wavelength? Distance between two consecutive compressions is called as wavelength, and SI unit of wavelength is meter, and wavelength is represented by a Greek letter lambda. Next what we learned was amplitude. Maximum displacement from the mean portion is called as amplitude, and it is represented by capital letter A. Next comes frequency. Frequency is the number of oscillations per second, and it is represented by a Greek letter called as mu. And for the simplicity in the video, we have represented it by f, and SI unit of frequency is hertz, and formula to find frequency is f is equal to 1 by t, where capital T represents time period. What is time period? Time period is time taken to complete one oscillation, and it is represented by capital T, and SI unit of time period is seconds. And then we learned speed of a wave. Speed of a wave is represented by small v, and SI unit is meter per second. Formula to find the speed of a wave is v is equal to lambda into f, where lambda represents the wavelength and f represents the frequency of the wave. I hope characteristics of some waves are clear. If you have any doubts, please feel free to post in the comment section below.